Hi guys, my name is Karan Shah, and in this session I'll discuss mixtures and allegation, various concepts, various formulas, shortcuts that will help you solve questions from mixtures and allegation in seconds. You can solve these questions using the shortcuts that I'm going to discuss, even while reading the question with 100% accuracy. You see, there are three topics of quant: ratio proportion, averages, and mixtures and allegation, which are so closely linked to each other that you need to understand these topics as a whole, as a total, to be able to solve questions. Allegation specifically is a derivative of averages, and today I'll show you how allegation is linked to weighted average, concept of weighted average, and how we can use that concept in solving the questions of allegation. There are two specific type of questions that occur very frequently in GMAT and CAT from mixed allegation, and I'll discuss those two type of questions in this particular session. Let's understand the relation between the allegation and weighted average. You see, what is weighted average? In weighted average, we usually have two or more than two groups of quantities with their own certain averages. So suppose this is one class with the mean of 40. Let's say the mean is of weight of the students of that class. And let's say there are 50 students in that class, right? Now let's say there is one more class, class 2, and let's say the mean of that class is 50 kg, and there are 30 students in that class, right? So there are two classes. One class has a mean of 40 kg, the second class has a mean of 50 kg, and the number of students are 50 students in the class 1 and 30 students in class 2. How do we calculate the overall average in this case? Overall average is calculated, or weighted average, weighted average is calculated by multiplying the mean with the number, basically taking out the sum of both the classes, sum of the weights of both the classes, adding them to calculate the total weight, and divided by the total number of students. Right? This is the way that we solve the questions from weighted average. This is the concept. This is the formula that we use to solve the questions from weighted averages. We multiply the means and the respective number of quantities, the number of students, or number of whatever items you have, of which average is given to us, and then we divide it with, we add the sum of all the groups that we have, and then we divide that sum with the total number of people, total number of items that we have in our question, right? This is how we solve questions from weighted average. But can we link weighted average to allegation somehow? Let's see. Now see, you have certain groups. Let's take two groups again. And let's say the mean of this group is M1 and mean of this group is M2, right? Let's say the number of people in this group is N1, number of people in this group is N2. And there has to be a weighted mean, a weighted average. Let's take it as M, right? Now, if there are two means M1 and M2 of two different groups, of course, there has to be one number out of M1 and M2 which is smaller than the other. Let's assume that M1 is smaller than M2, right? Now, because if they both are equal, then of course their weighted average will also be equal to whatever average that both groups have. And therefore, if there has to be a mean, and if M1 is less than M2, this mean would lie between both these numbers, right? It could be equal only if M1 and M2 are equal to each other as well, right? So mean of both these groups would lie between M1 and M2. This is something that we have to be very clear with, right? Okay. Now, our formula for the weighted average is M with is equal to M1 N1 plus m2 n2 upon n1 plus n2, right? Let's take this there. Let's take the denominator on the left side, n1 plus n2 n2, right? Now this becomes m n1 plus m n2 is equal to m1 n1 n2 n2, right? So let's take m1 n1 to the left side and mn2 to the right side. mn1 minus m1 n1 is equal to m2 n2, sorry, m2 n2 minus m n2. This becomes n1 m minus m1 is equal to n2 m2 minus m, right? Let's continue here. This becomes n1 upon n2 is equal to m minus m1, m2 minus m upon m minus m1. Now look at this very carefully. What does this formula say? What does this formula convey? This formula is basically the ratio of number of people in group 1, this is group 1, and number of people in group 2. Their ratio, it's n1 upon n2. This formula gives us the ratio in which both the groups were mixed or both the groups were taken together while calculating a common mean of those two groups. You understand this? If there are two groups with different means m1 and n2, then in what ratio should these groups be mixed together? In what ratio should these groups be added such that their common mean, their weighted mean is m? If you need to calculate this, this is n1 by n2 is m2 minus m, the larger mean minus the average mean that we need to get upon average mean minus the smaller mean of the group, right? This is what is allegation, correct? In allegation, we have a question in which we are sometimes given, there are given two mixtures, and those two mixtures are added together. When two mixtures are added together, there is in the first mixture there is a concentration of a certain liquid or a certain item, and second liquid in the second mixture there is another concentration of that same liquid or item, and then when they are added together we are given a final concentration and we are asked to calculate the ratio in which those two mixtures are mixed together. The ratio in which both the mixtures are mixed together is n1 by n2. This is the ratio, would be equal to, take the group with the higher mean, subtract from it the average mean that we need to reach at, correct? And then, or if you are looking at the concentration of the mixture, take the higher concentration, subtract the final concentration that we need to reach at, upon, take the final concentration and subtract the lower concentration that we need to reach at. I'll show you with an example. See, let's solve this question. The question says a chemist mixes two liquids, liquid 1 and liquid 2. 1 liter of liquid 1 weighs 1 kg and 1 liter of liquid 2 weighs 800 grams. If half liter of the mixture weighs 480 grams, then the percentage of liquid 1 in the mixture in terms of volume is, right? So we have two liquids, liquid 1 and this is liquid 2. Now 1 liter of this liquid weighs 1000 grams, 1 kg, and for this it weighs 800 grams per liter. When they are mixed together, their average weight basically per liter becomes 960 grams. We are given 480 grams per half a liter, so we'll convert it to per liter to keep the units constant. So per liter it weighs 1000 grams, per liter it weighs 800 grams, overall it weighs 960 grams, right? So if we have to find the final ratio, let's go back to the formula once. Now if you have to find the final ratio, let's think about the formula again. Formula said Q1 by Q2 or N1 by N2 would be second mean minus the overall mean right, upon the overall mean minus the first mean, right? Just remember the formula is this. Do not remember the formula as the higher mean minus the lower mean and all these things, because sometimes it is also possible that the higher mean is written on the left side, correct? Or the quantity that you need to calculate, the ratio that you need to calculate, the higher mean is in the numerator, right? So in that case, you may have to shift everything accordingly. So it's better to remember this formula as if you want to calculate Q1 upon Q2, right? Then you will have to subtract M2 minus M, and in the denominator it will be M minus M1. So second mean minus the average mean upon the average mean minus the first mean. Just remember this like this, right? So this is Q1, this is M2. It's the opposite. So use the formula. M2 is 800 grams, M is 960, M is 960 minus M1 is 1000 grams, which will give us minus 160 upon minus 40, it will give us 4 by 1. So Q1 by Q2 is 4 by 1. If Q1 by Q2 is 4 by 1, but you are asked the percentage of liquid 1 in the mixture. So Q1 will be 4 by 5 of the total, right? So if you need to calculate the percentage, it will be 4 by 5 of 100% will be 80%. It will help you solve the questions with so much efficiency that you will start loving the shortcut. See, bottle 1 contains a mixture of milk and water in 7:2 ratio. Bottle 2 contains a mixture of milk and water in 9:4 ratio. In what ratio of the volume should the liquids in bottle 1 and bottle 2 be combined to obtain a mixture of milk and water in 3:1 ratio? Right? So we are again given everything like the previous question, only that in that question we were given the volume per or weight per liter of two mixtures. In this case, we are given the ratios of two different type of things, two different type of items in two different bottles, right? So we can use the ratios as well to solve the question with the same shortcut that we used in the previous question. What we'll do is we'll start with the next. So we have an X, right? Now for bottle one, milk is in the ratio of 7:9. Just remember this. You cannot take the ratio of milk and water here. You cannot take 7/2 here, right? It has to be any one quantity. You have to select one quantity. It can be milk, it can be water, but you cannot take the ratio of both the quantities in this shortcut. And this is the only thing that you need to remember in the shortcut. So this is 7/9. This is 9/13, right? The final ratio that we need to reach is 3:1. So 3/4, right? Milk upon total. Now here subtract. Let's say I subtract 3/4 from 9/13. Let's say I do not want to get into which fraction is higher, which mean is higher, and I don't want to get into that stuff. So what I'll do is I'll just subtract 3/4 from 9/13. While I am subtracting 9/13 and 3/4 here, in this case, to get the value on the right side, I'll do just the opposite. I'll subtract 7/9 by 3/4. This we need to do. We need to take opposites on both the sides. If 3/4 is getting subtracted here, then the other number, the other fraction will be subtracted from 3/4 on the other side. Just remember this, right? It won't matter. It won't matter if you need to find the final ratio and if you are given the middle, the mean ratio, in this question. But it would matter if we are somehow not given, for example, this ratio or this ratio or this, and we need to find this. In that case, there can be a chance. There can be a possibility of making the mistakes if you do not do this, right? You just need to take, if you're subtracting 9/13 and 3/4 here, and 3/4 is getting subtracted, in this case the other fraction will get subtracted from 3/4. You just do not take 7/9 minus 3/4 here. It will be wrong, right? Now Q1 by Q2 would be 9/13 minus 3/4 upon 3/4 minus 7/9. So what we'll get here, we'll get minus 3 by 52, right? 36 minus 39 minus 3 upon 30 into 4, 52. Here you will get 27 minus 28 minus 1 by 36. So you will get 3 into 36 by 52, and if you divide it by 4, you will get 27 is 2. Right? In what ratio those two mixtures, bottle 1 and bottle 2 had to be mixed? It had to be in the ratio of 27 is to 30. Right? Very easy shortcut to use, and your questions, your answers will be so accurate if you start using this trick. And this question is from CAT 2019, and we could easily solve the question within seconds, right? See, there's a third type of question. Now, in this question, we are given the prices. One quality of wheat at rupees 9.30 kg is mixed with another quality at a certain rate in the ratio of 8:7. If the mixture so found be worth rupees 10 per kg, what is the rate per kg of the second quality of the wheat? So, in this question is a little twisted in the sense that we are given the prices and we are given the final ratios now, but we need to find the price of one of the quality of the wheat, right? The questions like these would be very frequently asked in your GMAT exam, and for GMAT, this trick is specifically helpful because you need speed there. In CAT as well, it's very applicable, it's very useful, right? But these type of questions particularly are very frequently asked in GMAT. Now, here you're given the quality of first wheat is priced at 9.3 kg. Just write 9.3 kg here. The second quality we need to calculate. Let's take it as X. The final quantity we are given, the final price of the mixture we are given, which is 10 per kg, right? We are also given the ratio in which they are mixed. Also remember that while using the shortcut, whatever ratio is given to you, if ratio is Q1 by Q2, it's the final ratio when these mixtures are mixed, it's Q1 upon Q2. Then here also the price has to be of the liquid one, or the quantity, or the item one, right? Do not interchange these positions. If you do this, your answer will be wrong, right? So if here it's Q1 upon Q2, take P1 here, right? Whatever ratio is given to you, you have to use these values corresponding to each other. You understand? If the ratio was given as the quantity of second to the quantity of first, then in that case we would have used X here and 9.3 here, right? Just remember this, because if you do not remember this, your answer will be completely wrong. So we are given the final ratio is 8:7, right? So what we'll do is here, so what we'll do here, we'll subtract this. 9.30 minus 10 is minus 0.7, right? And here 10 minus X, right? So because in this case we subtracted 10 from 9.3, in this case we'll subtract X from 10. It has to be done. So this ratio becomes 10 minus X upon minus 0.7, or X minus 10 upon 0.7, right? Or 10X minus 100 upon 7. Correct? So let's take it here now. Q1 by Q2 becomes 8 by 7. 10x minus 100 by 7. 8 becomes 10x minus 100. X becomes 10.8. Right? So the second quality of the wheat is priced at rupees 10.80. So as that the mixture is priced at rupees 10 when they are mixed in the ratio of 8:7. Now let's solve this question using a shortcut. Let's understand a shortcut now. Okay, so you have two liquids which are mixed together, and certain ratio, and that ratio we need to calculate so that there is a final weight per liter of the final mixture. What do we do in this shortcut is we make an X, right? Whatever ratio you need to calculate, if you need to calculate Q1 upon Q2, Q1 upon Q2, write everything about Q1, the first item on the left side of this X. So for Q1 or for liquid 1, it weighs 1000 grams per liter. Liquid 2 weighs 800 grams per liter. The final weight that you need to get, write that down in the middle of this X, in the center of this X, right? Now, here, subtract 800 and 960, right? Subtract 960 from 800, right? It would be minus 160. Here, subtract 1000 from 960. It will be minus 40. You could do the reverse as well. You could subtract 800 from 960 and then subtract 960 from 1000 here, right? But remember, if you are subtracting this quantity from this quantity on this side, then in the while getting this value on the right side, you will do the reverse. You cannot subtract this value from this value then, right? You'll have to subtract this value from this particular value on the to get this value, to get the value on the right side, right? It has to be reversed. Now, see again, Q1 by Q2 would be minus 60 upon minus 40, 4 by 1, right? So this is a very, very useful shortcut that you can use in the questions of allegation. And this is, you'll see that this is a shortcut that will help you solve any question with 100% accuracy within seconds. You can solve any question, whether you're given the volumes in that question, whether you're given the percentages of the concentration in two liquids, or if you're given the ratio of two different liquids in mixture 1 and two different liquids in mixture 2, and then both the mixtures are added to reach a final volume, final ratio. In that case also you can use this formula. So I'll solve a couple more questions to make you understand, to help you understand that this is a very useful formula that you can use in the questions of allegation. And so see this question now. The question says, from a container full of pure milk, 20% is replaced with water, and this process is repeated 2 more times. At the end of the third operation, the quantity of pure milk reduces. Right? So you're given the options, the answer in percentage. You need to calculate the percentage of pure liquid at the end of these 3 total replacements. Right? There are 3 total replacements now. So there is some pure milk in container. Let's say y liter milk, and out of this y liter, some x is being replaced, which is 0.2 of y, 20% of y, right? And then this process is repeated 2 more times. So this process has been repeated a total of 3 times. N is 3, right? By the end of the third operation, the quantity of pure milk reduces to, basically we need to find the percentage of pure milk at the end of these 3 replacements. And so we'll use the percentage formula here. Percentage of pure milk, it is 1 minus x upon y, n into 100%. That's it. A simple formula. We'll put in the values. 1 minus 0.2 y upon y power 3 into 100%. 0.8 power 3 into 100%. And the answer will be 8 into 8, 64, 64 into 8, 512, 51.2%. C is the correct answer. Right? These are 2 types of questions that are very important as long as mixtures and allegation, the topic of mixtures and allegation is concerned. And you need to understand these 2 questions very carefully, as these are very frequently repeated in both CAT and GMAT. And that's why you need to understand these shortcuts as well, because shortcuts would help you efficiently solve these questions with high accuracy and high speed. Start learning these shortcuts and start using these shortcuts, start implementing them while you're practicing at home as well. Do not just think that you can use these shortcuts on the day of the exam. implement them and use them very often while you're solving the questions during your own practice time, right? So this is all that I wanted to discuss in this video, and keep watching our videos. If you have any feedback, if you have any questions, you can write down in the comment section and we'll definitely get back. Keep practicing and all the best. So these are the questions which involve, these are the one type of questions from Mixtures and Allegation, and there is one more type of question that I would like to discuss, and the question is replacement in a pure liquid type of question. And in this question, you would have a container which will be probably filled to a certain volume with a pure liquid. Right? Pure liquid means this is not a mixture. It's a pure liquid. It can be water, it can be wine, it can be milk, it can be any other liquid, but it has to be pure liquid. There is no mixture inside it. Right? There would be a container. It will be filled with pure liquid. Let's say Y liters. Now, out of this pure liquid, some X liters will be taken out. X liters of that pure liquid from this container, it will be taken out and then replaced with some other liquid. Replaced with a new liquid. Right? So that X liters of the pure liquid out of the Y liter, out of the total quantity of Y liter, X liters from some quantity is taken out and it is replaced with a new liquid. That new liquid can be any other liquid except the pure liquid that was already there. Right? Now this step, this replacement, it can be one time or it can be repeated again and again. Right? How is it repeated? Now when there is a replacement with a new liquid, you have a mixture in the container now. Right? You have a mixture in the container in which X liter is the new liquid and Y minus X is the pure liquid left in the container. Correct? Now the whole process can be repeated once again. Again, X liter of this mixture is taken out. Again, X liter of the mixture is taken out and it is replaced with that new liquid again. Not a third liquid, but the second type of liquid that was that X liter was replaced with. Right? So this basically the first step, whatever happened here, this has been repeated. Right? And this repetition can go on. This can be for 5 times, 6 times, any number of times. Right? So in a question like this, we have a very simple formula. The formula that we can use, and that formula is a depreciation formula. Right? So basically, Y liter of liquid is being reduced every time with a particular ratio. Right? So what is that formula? It's a very simple formula, and the formula is that pure liquid left in the container after n replacements. N replacements means if the replacement has been, this process has been repeated n times. For example, this was done first and then 2 more times. There are 3 times this process has gone on for 3 times, right? So if pure liquid left, so the pure liquid left after n replacements, formula for this is y. The very simple formula y, 1 minus x. X is the part of the liquid that was replaced in the first case, upon y again to the power n. That's it. You do not have to use ratio or proportion. You do not have to form long equations to find the answer. You only have to use this simple formula to solve a question like this. Right? Pure liquid left after n replacements is y, 1 minus x by y. Now this formula can be a little tweaked, and if you are asked to find the ratio of pure liquid to total liquid after n replacements. Now just look here. I'm asking you to find the ratio of pure liquid to total liquid after n replacements. This is pure liquid basically. This formula is for pure liquid. If I need to find the ratio of pure liquid to the total liquid, I need to just divide this by y, right? Because y is the total liquid, total volume of that container. This will become 1 minus x by y power n. Simple, right? Now, if you are asked percentage of pure liquid left, it's easy, right? You understand that where we are going with this. Percentage of pure liquid left after replacements. This becomes 1 minus x by y power n into 100%. That's it, right? We will use these simple three formulas to solve questions like these, right? Let's solve some questions. A container contains 40 liters of milk. From this container, 4 liters of milk was taken out and replaced with water. You understand? So there is a container which has 40 liters of milk already, right? So this 40 liters is our y. Out of this, 4 liters was taken out and replaced with water. For x is 4 liters. This process was repeated further 2 times. Further 2 times means in total this process was done 3 times, right? So in total this process was done 3 times. How much milk is now contained in the container? So how much pure liquid is left in that container? So pure liquid is y 1 minus x by y power n, which is 40. 1 minus 4 by 40 power 3, right? 40 into this is 1 upon 10.1, 0.9, 0.9 into 0.9 into 0.9, right? 40 into 0.729, correct? What would be the final answer? It will be 29.16 liters. If you calculate this, if you find the product of these two, you'll find the final answer as 29.16 liters. But if you do not want to multiply this is just a calculation shortcut that I'm telling you here. This is 729, this is 40. You have 9 at the unit place. 9 when multiplied with 4 will give you 6 at the end, right? It may not be in the unit place, but there will be 6 at the end. So 2 answers possible were B and D, right? Also 7, this is 729. So 4 is being multiplied with, basically if we take this 0 here, 10 is multiplied to 0.729, 4 is being multiplied to 7.29. So 4 into 7 is 28. So if 4 is multiplied with 7.29, it has to be greater than 28. So this is something that I used to quickly, mark the answer. So it has to be greater than 28. There has to be a 6 in the end. The answer would be D, 29.16. And so you can use these calculation shortcuts as well in your calculations in both quant and DI in both the cases. You have to be very clear with the concepts of number system, concepts of divisibility, multiplication, and factors and multipliers and everything. So that you are able to use these shortcuts, you are able to implement these shortcuts just subconsciously while you're solving the questions.